Did you know that most drivers are unknowingly putting their engines at risk every time they choose motor oil? And here's the shocking part. More than half of American drivers are using an oil viscosity that doesn't match what their engine actually needs. This simple mistake can lead to unnecessary fuel consumption, increased wear, and in some cases, catastrophic engine damage that could have been completely avoided. So before we go any further, make sure you subscribe to the channel and turn on notifications, because the information you're about to hear can genuinely save your engine and your wallet. For years, people assumed that oil viscosity recommendations were simply straightforward engineering decisions. But as I dug deeper into published industry data, independent lab testing, and insights from multiple engine design experts, a very different picture emerged. Over the past decade, the push toward thinner and thinner oils isn't just an engineering trend, it's a complex mix of fuel regulations, corporate strategies, and evolving engine designs. And understanding what viscosity actually suits your vehicle can mean the difference between long-term reliability and premature failure. Today, I'm breaking down the real-world performance differences between 0W20 and 5W30 oils. Not the marketing version, not the oversimplified owner's manual version, but the full technical truth that manufacturers and oil companies rarely explain in detail. By the end of this video, you'll know how viscosity affects your specific engine, what type of driving conditions influence the best oil choice, and how to choose oil based on engineering, not trends. So let's start with a question. Have you noticed oil recommendations getting thinner with every new model year? Because that's not an accident, and the reason behind it might surprise you. Section 1. Why oil viscosity has changed so much. A decade ago, 5W30 was the most common oil viscosity across American vehicles. It offered reliable cold start lubrication and strong protection at high operating temperatures. But suddenly, 0W20 and even 0W16 started appearing everywhere, from sedans to trucks to SUVs. So what changed? After reviewing multiple engineering papers, Energy Department test data, and interviews from powertrain specialists, it became clear that four major forces are driving the shift: stricter fuel economy regulations. Even a tiny reduction in internal friction helps manufacturers meet government standards. Warranty period strategy. Automakers optimize performance only within the warranty window, not necessarily long-term durability. Tighter engine tolerances and new materials. Emissions requirements that demand faster warm-up times. These factors absolutely matter, but they don't tell the whole story. When engineers design around thinner oils, everything from bearing clearances to oil pump behavior changes. But for older engines, high-mileage vehicles, turbocharged setups, or severe driving conditions, these thinner oils may not always deliver the best protection. And that's where understanding viscosity becomes crucial. Section 2. What viscosity numbers actually mean. Let's simplify the numbers without losing accuracy. The first number, 0W or 5W, tells you how the oil flows when the engine is cold. The second number, 20 or 30, indicates oil thickness at 212 Fahrenheit, the engine's normal operating temperature. Lower numbers equals thinner oil. Thinner oil flows faster but offers a thinner protective film. Thicker oil protects better under stress but resists flow more. 0W20 is designed for quick circulation. 5W30 is designed for better high-temperature protection. Both have advantages depending on the engine and driving conditions. Section 3. Cold start performance. 0W versus 5W. Cold starts create more engine wear than any other moment. When oil is thick and slow to move, metal parts contact each other before lubrication reaches them. Testing performed in cold climate simulations shows 0W oils reach critical engine components between 1-3 seconds faster than 5W oils at extremely low temperatures. Over hundreds of cold starts, this difference can translate into noticeable cumulative wear reduction. But here's the important part. This advantage becomes meaningful only in very cold regions, typically below 0 degrees Fahrenheit, minus 18 degrees Celsius. For drivers in normal climates, California, Texas, Florida, the southern US, or similar regions, testing shows no measurable difference in long-term wear between 0W and 5W cold start performance. So if you don't live where winters are brutal, the cold start advantage of 0W oils doesn't actually matter much. And for extremely cold climates, 0W oils do shine. For moderate climates, the difference becomes almost irrelevant. Section 4. Operating temperature performance, 20 versus 30. This is where the biggest differences appear. Once the engine is warm, the second number determines how thick the oil film remains under stress. Independent lab testing shows that 5W30 maintains a noticeably thicker oil film at high temperatures than 0W20. In high-load situations like towing, hauling, aggressive acceleration, or high-heat environments, 0W20 can shear down faster, reducing the thickness of the oil film. A thinner oil film equals more metal-to-metal contact equals increased wear. Studies comparing identical engines found that engines running 5W30 showed up to 22% less cam lobe wear and up to 18% less main bearing wear under high-stress conditions. That's not small. That's the difference between a healthy engine and one that starts consuming oil or losing performance. This is why many turbocharged engines, older engines, and vehicles used for towing often benefit from 5W30 rather than 0W20. Section 5. Why thinner oils improve fuel economy. Automakers love thin oils because thinner oils reduce pumping losses. The less resistance the oil creates, the less power the engine wastes pushing it through the system. Testing shows switching from 5W30 to 0W20 typically improves fuel economy 1–2%. For a normal driver, that works out to maybe $25 to $50 per year. Not nothing, but not life-changing either. But multiply that tiny advantage across millions of vehicles in an automaker's fleet. And suddenly, it becomes the difference between meeting government fuel economy targets or paying millions in penalties. Manufacturers are not switching viscosity for your engine's longevity. They are switching viscosity for fuel economy compliance. For brand new engines specifically designed around thin oils, this isn't a problem. But for older engines or high-stress vehicles, it can be. Section 6. Why some modern engines actually need 0W20. It's important to be fair. Some engines are genuinely engineered from the ground up to run on thinner oils. Modern powertrains often include extremely tight tolerances, advanced coatings, variable displacement oil pumps, hydraulic systems requiring fast oil movement, precision valve timing systems. These engines rely on thinner oil for proper hydraulic function. Put a thicker oil in these engines and you can actually cause problems. Higher oil pressure, slower hydraulic response, reduced efficiency, possible VVT malfunctions. So for engines designed for 0W20, stick with it. Section 7. When 5W30 is actually the better choice. Though the industry is pushing thin oils, several real-world situations still favor 5W30. Reason 1. High-mileage engines. As engines wear, clearances get bigger. A slightly thicker oil helps maintain compression and reduce consumption. Reason 2. Turbocharged engines. Turbochargers get extremely hot. Thicker oil protects bearings better under extreme heat. Reason 3. Severe service driving. Severe service driving. If you tow, haul, drive in deserts, or push the engine hard, 5W30 offers significantly better film strength. Reason 4. Pre-2010 engine designs. Engines built before the ultra-thin oil era were simply not engineered for 0W20. Reason 5. Engines that consume oil, thinner oils often worsen consumption issues. Switching to 5W30 frequently reduces or eliminates consumption completely. Section 8. Real-world data from labs and fleets. Let's talk about what actually happens in the real world, not theory. Oil analysis. Laboratories. Comparing thousands of samples, 0W20 oils often show 15 to 25% higher wear metals versus 5W30 in identical engines. Commercial fleet. Data mixed fleets using both oils revealed Vehicles using 5W30 lasted 7 to 12% longer before needing major engine work. Consumer testing organizations found new engines designed for 0W20 show no issues using it. Older designs show clear advantages with 5W30. Temperature stability 5W30 holds its viscosity better in heat. 0W20 breaks down faster under sustained high-temperature operation. All this data leads to one clear conclusion. There is no universal best oil. There is only the best oil for your engine and your driving conditions. Section 9. How to choose the right viscosity. Here's a simple breakdown. Choose 0W20 if your car was engineered specifically for it. You want maximum fuel economy. You live in extremely cold climates. You drive normally and rarely tow or haul. Choose 5W30 if your engine has over 75,000 miles. You tow, haul, drive in heat, or drive aggressively. You own a turbocharged engine. Your car is older or wasn't engineered for thin oils. You are experiencing oil consumption. Oil viscosity is not one size fits all. It's not just about what the manual says, it's about how you drive, where you drive, how old your engine is, and what the engine was originally designed around. Manufacturers choose viscosity for fuel economy targets. You should choose viscosity for engine life. If this video helped you understand oil viscosity better, make sure you hit the like button. It really supports the channel. And don't forget to subscribe because next week, I'm breaking down the truth about extended oil change intervals and why following factory recommendations might not always be the best choice for your engine. Let me know in the comments. What viscosity are you running right now, and have you ever switched? Your experience could help someone else make the right decision. Knowledge is power, especially when it comes to protecting your engine.